This is SpaceTime, Series 23, Episode 10. Coming up on SpaceTime. Intriguing new results which could possibly crack the standard model of particle physics. Dating a Milky Way feeding frenzy. And more evidence that an asteroid impact killed the dinosaurs. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Physicists at CERN, the European Organisation for Nuclear Research, have come up with some intriguing new results which, if confirmed by follow-up studies, could end up breaking the standard model of particle physics, the very foundations upon which science's understanding of the universe are based. Researchers with the LHCb experiment at the Large Hadron Collider, the world's largest atom smasher, have detected a possible difference in the behaviour of different types of elemental particles called leptons. The authors have been studying a key principle of the standard model called lepton universality, in which all three types of charged lepton particles, electrons, muons and taus, interact in the same way with other particles. So the different types of leptons should be created equally in particle transformations or decays once the differences in their masses are taken into account. The problem is, some LHCb particle decay measurements have started to show suggestions that this may not be the case. Now, the findings aren't statistically significant yet, but they do match other results both by the LHCb team and by scientists at other institutions which have found similar differences. And if these were confirmed through enough follow-up experiments, would signal a crack in the standard model of particle physics. The LHCb experiment reached their findings by sifting through proton-proton collision data measuring the decay of beauty baryons. Beauty baryons are made up of three quark particles containing at least one bottom quark. Quarks are elemental subatomic particles and a fundamental constituent of matter. They combine to form composite particles called hadrons, the most stable of which are the protons and neutrons which make up atomic nuclei. There are 6 types of quarks known as flavors: up, down, top, bottom, sometimes called beauty, charm and strange. The up and down quarks have the lowest masses and are the most stable. The proton is composed of 2 up quarks and a down quark, while the neutron 1 up quark and 2 down quarks. The heavier quarks rapidly change into up and down quarks through a process of particle decay, the transformation from a heavier mass state to a lower mass state. The LHCb team were measuring how often these beauty baryons decayed into a proton, a charged kaon, and either a muon and antimuon, or an electron and anti-electron. Now, lepton universality predicts this ratio should be close to 1:1, and any significant deviation from this could signal a violation, possibly due to the presence of a never-before-seen particle in the decay which had not been predicted by the standard model. And this is where it gets interesting. What the researchers found is that decays to a muon-antimuon pair occurred less often than those to an electron-anti-electron pair. Now, the difference wasn't much, with the ratio only being slightly below 1:1, with a statistical significance of about 1 standard deviation, which is well below the 5 sigma standard deviations needed to claim a real difference in the decay rates. Still, the results do point in the same direction as the other findings. But much more data will be needed to determine whether this oddity in the behaviour of leptons is real or just a statistical artifact. The Large Hadron Collider, or LHC, is a 27-kilometre-long ring buried 100 metres beneath the Franco-Swiss border near Geneva. Part of a large complex of particle accelerators, synchrotrons and other high-energy laboratories, the LHC includes 4 massive detectors called Atlas, Alice, CMS and LHCb, located in 4 huge underground caverns. Packets of protons or other subatomic particles are accelerated to within 99.9999% the speed of light in opposite directions in 2 particle beamlines around the ring, guided by cryogenically cooled superconducting magnets. The beamlines can intersect at any of the 4 detectors, colliding the particle packets and creating the sorts of conditions, pressures and temperatures that occurred just after the Big Bang 13.82 billion years ago. You're listening to SpaceTime. Still to come, dating a feeding frenzy which changed the Milky Way galaxy forever, the first Ariane 5 launch for 2020, And later in the science report, researchers managed to culture microorganisms in the lab from which all complex life on Earth may have descended. All that and more coming up on SpaceTime. A single bright star in the Southern Hemisphere constellation Indus has revealed new insights on the Milky Way's cannibalization of the small dwarf galaxy Gaia-Enceladus. The findings, reported in the journal Nature Astronomy, suggest that Gaia-Enceladus collided with and was merged into the Milky Way some 11.5 billion years ago. That's some 7 billion years before the birth of the Earth, Sun and Solar System. Cosmology has taught us that galaxies grow through merging with other galaxies. But these collisions leave clear traces, such as streams of stars moving in a different direction and at a different velocity compared to other stars in the galaxy. Also, the stars will have very different chemical compositions compared to other stars in the galaxy. And mergers will also trigger starburst, the sudden creation of large numbers of new stars. The Milky Way galaxy has also grown by cannibalizing numerous other galaxies during its 13.5 billion year history. And it's continuing to do so today. In fact, right now it's consuming at least 3 galaxies we know of. There's the Sagittarius dwarf galaxy, which is being gobbled up on the far side of the Milky Way, and in our neck of the woods, there's the large and small Magellanic Clouds, which are already losing streams of gas and stars to the Milky Way through structures like the Magellanic Bridge and Stream. And of course, the Milky Way itself will be consumed in about 4 billion years from now by an even larger galaxy, M31 in Andromeda. In this new study, astronomers used a star called New Indy as a probe, using NASA's Transiting Exoplanet Survey satellite TESS to study its natural oscillations or brightness fluctuations using a process called astroseismology. These brightness fluctuations provide clues about a star's physical structure and properties, allowing astronomers to gauge a star's stage of development, factor in its luminosity, and estimate its age. Launched in 2018, TESS is surveying the sky to search for planets transiting, that is, passing in front of their host stars. When a planet does this, it causes a slight dip in starlight as it's blocked out by the orbiting planet. The authors from our study also obtained spectroscopic data on New Indy from the European Southern Observatory in Chile, the Galaxy Evolution Experiment at the Apache Point Observatory in New Mexico, and the European Space Agency's Gaia Space Telescope. The spectroscopic data allowed researchers to determine both the star's chemical composition and also its proper movement across the sky. New Indy is about as bright as the planet Uranus, and it's visible with the unaided eye. It's one of the Milky Way's halo stars. That's an ancient and sparse spherical population of stars and globular clusters thought to surround the outskirts of most spiral galaxies. When all the observations were combined, the authors found that New Indy was born early in the life of the Milky Way, and that the Gaia-Enceladus collision altered its motion through the galaxy. The study's lead author, Bill Chaplin from the University of Birmingham, says because the motion of New Indy was affected by the Gaia-Enceladus collision, it means the collision must have happened after the star had formed, allowing scientists to place new limits on when the Gaia-Enceladus event occurred. And because astronomers are seeing so many stars from the Gaia-Enceladus event, they think the collision must have had a huge impact on the evolution of the Milky Way. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, we're going to talk about a lonely, lonely star in a galaxy not far away.
Yeah, very nearby, in fact, the one that we belong to. Yeah, it's a nice story. Once again, it's a story with multi-facets, which, of course, is always good when you've got some astronomy. You can pull in different bits of astronomy to build a big picture. So the star you're talking about rejoices in the name of New Indy.
Oh, I like that.
And the new is not NEW, it's NU. It's the Greek letter nu, which is kind of halfway through the Greek alphabet. And since Greek letters are only assigned to pretty bright stars because they were the ones that were being observed in the dawn of the invention of the telescope, that tells you that this is a star that can be seen by the naked eye. It's not particularly bright. You kind of need to know where to look, but it is possible to see it with the unaided eye. Why is it New Indy and not New something else? Indy is the genitive format, is that right? I'm using the right term there, I think I am, yeah, of the constellation Indus, the Indian. So New Indy means new of Indus. It's like all bright stars are named with a Greek letter and then this genitive form of I think I'm using the wrong term there, I can't remember. So long since I've looked at this stuff.
It's jet lag again, Fred.
The constellation name.
Jet lag.
No, it's jet lag, yeah. Gosh, yeah, I know. Could do without that. Never mind.
They have to develop a pill for that, I reckon.
Yeah,
somebody came up with a jet lag pill.
Actually, what you do is you use light because light is one that regulates your circadian rhythms. So if you can beam yourself with the right kind of light, that can reset your clocks, and you're off on a good thing. Anyway, that's a slightly off the story topic, but we can talk about that some other time. So what's special about New Indy? It's a star first of all, it's a very old star. Scientists from a number of different institutions, including one here in Australia, the University of New South Wales. Scientists there have observed this star with a spacecraft called TESS. And you and I have talked about TESS before because it's the one that finds planets going around other stars by the fact that the planets dim the light of the star as it passes in front. So TESS is very good at making really sensitive measurements of the brightness of stars. Now, at the kind of level that TESS can detect, there are other things besides planets passing in front of stars that make them go dim. And one of them is that stars themselves have an intrinsic vibration. They ring a bit like a bell. Our sun does that. If I remember rightly, the sun's period of oscillation is about 5 minutes, something of that sort.
Okay.
This whole science is called asteroseismology, and it's about measuring star quakes. So you can learn a lot by looking at the way a star rings like a bell. And New Indy has the kind of vibrations that you only get from a star that is very old. And in fact, it turns out that you can use these vibrations to make a very accurate estimate of the age of a star. It's actually one of the most accurate ways of estimating the age of a star. And it comes out for New Indy at 11 billion years. That's its age. It's actually, I'm looking at the original paper here, 11.0 plus or minus 0.7 billion years. So there's a 700 million year uncertainty on that, but that is pretty damn good for something that's 11 billion years old. Yes. So the age of the star has been well established. However, this star has another attribute which singles it out as being unusual, and that is its motion, because it's moving in a way that suggests it was disturbed by a collision between our own galaxy and one of the dwarf galaxies that it has absorbed in order to build up its present size. And that the movement of New Indy suggests that it was disturbed by a small galaxy called Gaia-Enceladus, that's its name, when it basically crashed into the young Milky Way. Now, that piece of information, so associating the motion of New Indy with the collision, essentially gives you a date for the collision. There's other factors come into this as well, not just the motion of the star, but some aspects of its chemical composition that associate it with this collision with the Gaia-Enceladus dwarf galaxy. And what that has done is allowed scientists to date the collision with the dwarf galaxy. And so we now have a date probably of about 11.5 billion years ago for when this collision took place, because we know the age of the star. It's a very nice piece of work, linking one thing with another and, determining something that would otherwise seem to be very hard to find out about.
Yes, indeed. Do we know, and I may have asked you this before, do we know how many galaxies make up our galaxy?
No, that's a really good question. It's something that's constantly being worked on, because all of these galaxies that were absorbed by our own essentially leave fossils in terms of the motions of stars within our own galaxy. So if you find a whole group of stars that have got a common motion, they're all moving the same way, but they're within our galaxy, what you can say is these probably are the remnant debris of a galaxy that was gobbled up by our own. So what's revolutionized our studies of this is the Gaia spacecraft, and that's why that galaxy is called Gaia-Enceladus, because Gaia is a spacecraft which was launched probably about 5 years ago. I can't remember the details. It's a European Space Agency spacecraft, and it is very accurately measuring the positions and velocities of stars. And so we now have a catalogue of, I think it's something like 1.5 billion stars whose motions we know well. And it's from that set of data that you can start picking out stars with a common motion and working out these stars belong to a distant galaxy. galaxy. So I don't know what the total is at the moment. It's probably something like 15 or 20 that we know about, but there might very well be many, many more that went to make up the galaxy as we see it today.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. There's been another study showing how an asteroid impact rather than volcanic activity caused the mass extinction event 66 million years ago, which killed 75% of all life on Earth, including the non-avian dinosaurs. This latest research analysed marine fossils and climate modelling to show that the major release of volcanic gases thought by some to contribute to the extinction event actually happened about 200,000 years before the asteroid impact, thereby making the asteroid the sole cause for the extinction event. The new findings follow a separate study last year which came to the same conclusion based on algal fossil remains. The ongoing debate is centred around the simple fact that two planetary-scale disturbances, the Deccan Traps volcanic lava floods in India and the Chicxulub asteroid impact event, both occurred within less than 1 million years of each other, triggering one of the planet's largest ever mass extinction events. Now, the Deccan Traps was massive, a volcanic fissure, a split in the Earth, which released over 500,000 cubic kilometres of flood lava, in the process forming one of the largest volcanic features on the planet. Meanwhile, the Chicxulub asteroid impact created a 200-kilometre-wide crater when a 10-kilometre-wide asteroid slammed into Mexico's Yucatan Peninsula. This new study, reported in the journal Science, looked at the environmental impacts from the massive volcanic eruptions in India which formed the Deccan Traps Plateau. The authors also looked at ocean temperature and carbon cycle changes around the time of the extinction event using microscopic marine fossils and compared these records to models of the climatic effect of carbon dioxide release. This pinpointed the timing of the volcanic gas emissions to some 200,000 years before the extinction event. One of the study's authors, Professor Paul Wilson from the University of Southampton, says by focusing on the effects of the gases that were released rather than dating the rocks left behind by the Deccan eruptions, they found that volcanism began and ended distinctly prior to the mass extinction, while the impact event coincides precisely with the extinction. This means the volcanoes couldn't be a driver for this mass extinction event. They found that volcanic activity in the late Cretaceous caused only a gradual global warming of about 2 degrees. But from analysing deep-sea sediment sections drilled in the North and South Atlantic as well as the Pacific Oceans, this warming had no significant effect on marine ecosystems, and cooler conditions had already returned prior to the extinction. The KT, or Cretaceous Tertiary Boundary Event, which these days is more commonly referred to as the KPG, or Cretaceous Paleogene Extinction Event, released as much energy as 100 teratons of TNT. That's more than 1 billion times the energy of the Hiroshima and Nagasaki atomic bombs used to end World War II. Shockwaves from the asteroid impact circled the entire planet, triggering massive tsunami hundreds of meters high, together with devastating earthquakes and a phenomenon called land tsunamis. The impact threw molten ejecta and debris high into the atmosphere, resulting in burning debris raining back down onto the Earth's surface, causing global wildfires and an intense pulse of infrared radiation, which began cooking any life that survived the initial blast wave. To make matters worse, the asteroid impacted the planet at a location rich in sulfate-containing gypsum, which was instantly vaporized and dispersed as an aerosol into the atmosphere, only to rain back down as highly caustic acid rain, burning anything it touched and causing long-term effects on both the climate and food chain. Smoke, ash, dust and debris from the impact and the wildfires created a blanket greenhouse effect around the entire planet. Now, initially, this prevented heat from escaping and caused surface temperatures to soar. But eventually, temperatures cooled. With the smoke and debris still up there blocking out sunlight for months, if not years on end, it resulted in an impact winter, which caused temperatures around the planet to plummet. And evidence for the global nature of this impact can be seen around the planet in the form of a dark boundary line in the geologic record, known as the KT boundary. It contains high levels of the metal iridium, which is rare in Earth's crust, but is very abundant in asteroids. You're listening to Space Time. Still to come, the European Space Agency carries out its first Ariane 5 launch for the year, and later in the Science Report, a new study reports that damage to the ozone layer may be responsible for up to half of Arctic warming over the last 50 years. All that and more still to come on Space Time. The European Space Agency has carried out its first Ariane 5 launch for the year, carrying 2 telecommunications satellites into geostationary orbit. Ariane spaceflight VA251 blasted off from the European Space Agency's Kourou spaceport in French Guiana.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage du Vulcain. Allumage EAP et décollage. Les paramètres bord sont nominaux.
And we are off. Ariane 5 is blazing a trail across the equatorial skies,
La propulsion est nominale.
powering her way into space. Heading east, out over the Atlantic Ocean. We've broken the sound barrier, Mach 1. We're travelling faster than the speed of sound.
La trajectoire est nominale.
And we can just hear the sound of Ariane now coming to us here at the Jupiter Control Center overhead. Thundering overhead. Right now the boosters are doing all the work. They are providing 90% of our thrust. That's the equivalent of 12 jet engines.
La trajectoire est nominale.
Boosters are pushing us away from Earth's gravity, and we need a lot of firepower to do that. Each booster is burning 2 tons of propellant per second.
Les paramètres bord sont nominaux. Le pilotage est calme.
Now, what an average car uses in a year. The range operations manager is telling us that everything's going normally, as expected. So, Intelsat Connect and GSAT 30 have started their journey. Our altitude, we're presently 55 kilometers above the Earth.
La trajectoire est nominale.
Getting close now to the moment when we release the boosters. Here we go.
Séparation des EAP.
2 boosters moving away. They have used their propellant. They've burnt it all up, and we don't need them anymore. They are falling back to Earth in a very specific pattern to ensure collision avoidance. The main stage engine powering its way away from us, powering its way into space. We've already lost 3/4 of our weight in just over 2 minutes, and that's, of course, the aim of the game. The lighter we are, the faster we go. And now we're getting confirmation from the range operations manager that we have separated the fairing.
The 3,619-kilogram Eutelsat Connect spacecraft was the first to be deployed, 27 minutes after launch. The Thales Alenia space-built satellite uses the new Spacebus Neo platform, developed under a joint ESA-French Space Agency partnership project. Connect will provide broadband services across Europe and Africa for a design life of around 15 years. 11 minutes after the deployment of Connect, the 3,357-kilogram GSAT 30 satellite was also released. Developed by the Indian Space Research Organisation, it'll provide television, telecommunications and broadcasting services over the Indian subcontinent for the next 15 years. As well as being the first Ariane 5 flight for the year, it was also the 107th mission for the Ariane 5 launch vehicle. China has launched a new nano-communication satellite. The Galaxy 1 was flown aboard a Kuaizhou 1A rocket from the Jiuquan Satellite Launch Center in northwestern China's Gansu province. The Kuaizhou 1A is a small solar-fueled rocket designed to launch payloads up to 300 kilograms into low Earth orbits. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study claims damage to the ozone layer may have been responsible for half of the Arctic's warming over the last 50 years. The use of chlorofluorocarbons and other ozone-depleting chemicals has been curbed since the 1987 Montreal Protocol, except that is in China, where the use has actually been increasing. The findings, reported in the journal Nature Climate Change, show that the greenhouse gas effects of chlorofluorocarbons are still evident. Scientists modelled 2 situations, both with and without the gases, and estimated that between 1955 and 2005, nearly half of Arctic warming and nearly a third of globally averaged warming may have been caused by these ozone-depleting chemicals. Well, there's little doubt that the devastating fires which are ravaging Australia and have been for the past few months have been a major ecological disaster, with more than 1 billion animals killed and fears that entire species have been wiped out. Among all the death and destruction, there has been at least one tiny bit of good news, with specialist national parks firefighters and conservationists managing to save the world's last remaining grove of Wollemi pines. The irreplaceable trees, Wilhelmina nobilis, located deep in a secret gully, had survived since the age of the dinosaurs, but were facing annihilation as the massive mega-fire front approached. National Parks rangers and scientists came up with a plan using both an intense campaign of waterbombing aircraft and a specially designed irrigation sprinkler system to soak the ground and shield the rare trees from the worst of the flames as the mega-fire crossed the area. When the fires moved on, the entire landscape was blackened. But amazingly, there was one small green canyon which survived, containing the last of the Wollemi pines. A new study has found a link between fish oil supplements and improved sperm counts in humans. The findings, reported in the Journal of the American Medical Association, are based on examinations of 1,679 Danish teenagers aged around 18. Those who took the fish oil supplements also had higher semen volume, larger testicles, and high testosterone levels, compared to the teens who didn't take the capsules. And it seems the more fish oil supplements the guys took, the higher their sperm counts, semen volume, and testosterone levels were. Now, the authors stress that while this type of study can't show cause and effect, the fact that increasing doses of fish oil corresponded to the other increases could suggest a causal link. Scientists have for the first time ever cultured Asgardia archaea in the laboratory. They're the microorganisms from which all complex life may have descended. A report in the journal Nature claims scientists isolated the tentacled microbe from deep-sea sediments and then painstakingly grew it over 12 years. The archaeon microbe offers tantalizing hints as to how an ancient single-celled creature may have engulfed another to create more advanced eukaryotes, cells with complex internal structures that would eventually evolve to create fungi, plants, and animals, including humans. A new study claims that normal human body temperatures may have dropped by around half a degree since the 1860s. The normal human body temperature range is typically stated as 36.5 to 37.5 degrees Celsius. The surprising findings reported in the journal eLife are based on hundreds of thousands of thermometer measurements taken since the 1860s. Researchers found that average human body temperatures have been dropping by around 0.03 degrees Celsius per decade. However, not everyone's convinced, as there are numerous variables in how temperature is taken and how the accuracy of thermometers may have changed in the last 200 years. Then again, considering how common chronic inflammatory diseases were in the 19th century, the findings may not be all that surprising after all. Firehosing is the name being given to the latest strategy designed to stop intellectual debate on issues. The term was originally coined to describe the propaganda tactics now being used by Russian authorities to quell dissent and control the political landscape. But Tim Mendham from Australian Skeptics says it's now metastasized into a tactic being used by the likes of anti-vaxxers and climate change deniers.
Firehosing is a term that's used these days to indicate people who swamp you with information. Now, we're not talking bushfires, we're not talking people who do real things. This is an argument-based approach. Skeptics would know what's generally referred to as the Gish Gallop, which is based on a guy named Duane Gish, who ran a creation science foundation, I think was the name of it, in America. He was one of the father figures of the fundamentalist Christian creation science movement in America, and whenever he debated against someone who was saying evolution, 4 billion-year-old Earth, this sort of stuff, rather than the 6,000-year-old Earth that Duane Gish was promoting, he'd flood the debate with information, one after the other, after the other, after the other, that quickly, just rattling off facts in quotes, one after the other after the other. And this was the Gish Gallop.
Well, claims rather than facts, but yeah.
Yeah, well, facts in quotes, you know. He made them sound like they were facts, but they weren't. But he had so many of them and so quickly that the person responding just had no chance. The person on the other side of the debate didn't have a chance, certainly not to respond to all of them. And if you responded to one, you still missed the other 99 that you weren't able to. So it didn't come across very well. So after a while, people weren't debating with Duane Gish anymore because there was just no point. But the Gish Gallop still exists and people still do it. But now it's come into, rather than a one-on-one situation as it was with Gish and the Gallop in debates, it's now across social media, and you'll find yourself you're being bombarded with information from left, right and centre, whether it's Twitter or Facebook or you name it, from a whole range of different sources. And you are looking at that, oh, I've got so much information coming in, I'm overwhelmed by it, it must be true. And this is the idea that a lot of anecdotes don't make a lot of good data. But, I mean, if you have one bit of story from one source and then you find another bit of story from another source after a while you think, well, there's so much of it, it must be true. Our response is a bit of a claim that scores 2 out of 10, and having 5 of them doesn't make 10 out of 10. It makes 5 2 out of 10s. It's no better. A lot of bad evidence is not good evidence, and that's what fire hosing is just a gish gallop over a wide range of media and from a wide range of sources. It's the same thing.
That's Tim Mendham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the Spacetime with Stuart Gary YouTube channel. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.